Yes, Shahid, is it audible to you? Are you there? Shahid, is it audible? Please let me know. Shahid, is it now audible to you? Is it now audible, Shahid? Shahid, just text if you're present right now because you weren't responding to me. I have called out your name so many times. What happened, Shahid? Were you not there? Since I have shared the screen, I think 5 minutes. Speaker wasn't connected. Okay, okay. All right. Now I am audible to you, no? So it's fine. Let's start. Already 18 minutes have been wasted. I was waiting for you. See, I just want to start this lesson, magnetism and matter. So it's not a difficult lesson to handle in your JEE also. Just basic things that I want to revise it with you. This is suppose north polarity. This is south polarity. All right. Now see, when we talk about the Earth as a magnet, it's just a revision to what we have studied. Nothing different that you have not written in your notes. This is the magnetic North Pole. This is the magnetic North Pole, because this is not the actual North and South Pole of the Earth. This is the pole, this is the polarity when Earth behaves as a magnet. See, suppose this is actual North and South Pole. So that we term it as the geographic North and South. Geographic polarity. Geographic North Pole. This will become. So you have geographic North Pole, you have magnetic North Pole. Similarly, this is going to be, if this is North, this is South. This will be South, geographic South Pole. This will be magnetic South Pole. So when we'll be using the terms North Pole, South Pole, we'll be talking about magnetic North Pole. In your exam also that will come. And one axis will be there on the axis which Earth rotates, Earth's rotational axis. All right. And one more thing that according to the lines that you have to remember, this is the equator. This is the equator of the Earth. So what all things we have? Yes, Fadil, am I audible to you?
Yes, ma'am.
All right. So we have started with magnetism and matter. You can catch up with this. This is not a very difficult lesson to handle. Basic things we are revising, which we have to remember in here. Basically, Earth's magnetism is of prime importance to all of you. To any of you for JEE exam, especially, firstly, we have to cover this topic. Earth magnetism is the most important topic. Just remember one thing additional that we'll not be discussing in the batch, that this is actually given by William Gilbert in one of the exams. No, this was asked in one of the exams. William Gilbert. And he actually gave the term as geomagnetism. Earth magnetism is exactly geomagnetism only. Earth's magnetism. Fine. So, yes, this is the axis of the Earth. This is the geographical North Pole. Geographical North Pole, when I say it means the actual North Pole, which you have been studying in your geography, in your schools. Social studies, you must be studying North polarity, South polarity. So that you have studied in your lower classes. That I'm talking, saying, and that I'm naming it as geographic North Pole and South Pole. Then you have magnetic North Pole and South Pole. This is the polarity that is useful to us, and we'll be taking this as the reference. What is magnetic North Pole and magnetic South Pole? This is if Earth as a magnet. Means I can replace this entire Earth like a huge big bar magnet with this polarity. Then if I say North Pole now onwards, that doesn't mean this. This is geographic, this is magnetic. So just be careful when you are using these terms. And apart from this, you have to understand this axis. This axis is also called geographical axis. This axis is called geographical axis of the Earth. Then you have a geographic meridian. Geographic meridian basically passes through geographical axis of Earth only. And then you have geographic equator. This is also geographic equator. Geographic equator is what? It's a great circle on the surface of Earth. It is actually a circle on the surface of Earth in a plane perpendicular to this geographical axis. This axis and the equator, these are actually perpendicular to each other. I have not drawn it properly, but both of them are perpendicular to each other. And all points on the geographical equator are equal distant from the geographical poles. All the points. Suppose I have taken this point here. So if I'll take this point here, both will be at the same difference. This is such the uniqueness of equator. It divides it in such a way. Then some more terms that I want to discuss before we go on to the formula part. If you are having a basic magnet, now what all things are there if you are having a basic magnet? though these will be discussed in the class, some of the topics have been discussed also. One is the magnetic axis. This is the magnetic axis. And this is what? This is the equatorial axis. And the length of the magnet, that is separation between North Pole and South Pole, this is called magnetic length. This is a bar magnet. This is a regular bar magnet. So this separation is known as magnetic length, North Pole and South. This is the equatorial axis, which is making angle 90 degree. It's like equatorial point we take in your calculations of, remember axial, electric field, axial and equatorial. This is similar. Similarly, this is the axis. You extend it, you will have certain data. All right. This you have to remember in this, and from there that you have to remember, which I mentioned. Now coming to the angles and all that I'll discuss later. First, make it down separately, write it down. Then I'll discuss the formula part, angle of declination, angle of dip. That is important. And one more we'll also talk about. See, when we talk about the angle of dip and angle of inclination, let us quickly revise what was angle of dip and angle of inclination. Now, one extra thing that we'll study here is dip circle. That isn't part of your CBSE syllabus, but sometimes in JEE it can be asked or the term can be used. So that's why we'll discuss it over here. Now, see, I have just taken a horizontal reference line. That horizontal reference line is actually the geographical meridian. I'm drawing it in the form of lines because drawing it in the form of planes become very difficult, right? While we are drawing in the books, you can check it. All right. So see, now you are having a magnetic field. Suppose this is the magnetic field. This here you are having magnetic meridian. One of them, this is geographical meridian. Let me just name it. This is geographical meridian. Like this line wise, remember, I'm just drawing it in the form of line. This is geographical meridian. This is magnetic meridian. This is magnetic field. This angle that the magnetic field makes with the magnetic meridian, this is called angle of dip. These are just angles for the calculation purposes. Then the angle that magnetic meridian and geographical meridian are having between them, that angle is known as angle of declination. This is angle of declination. All right, this is angle of declination. Now we have a very basic formula. Formulas I'm just writing straight away. Derivation, Fadil, you will do in your batch. Shahid, you have already done. When we resolve these, this is B, so this becomes B cos theta, this becomes B sin theta. So this is actually the vertical component, this is actually the horizontal component. And this is the vertical component of magnetic. Now coming to the formula, horizontal component of magnetic field is B cos theta. Vertical component of magnetic field is B sin theta. Now tan theta is equal to BV by BH. B is equal to under root BH square plus BV square. These are all the formulas that you have to remember, max. Now, one term that I was mentioning, no, that will come apart from this is known as dip circle. This is called dip circle. So, angle of dip circle basically helps to measure angle of. And what is angle of dip? Angle that the magnetic field makes with the magnetic meridian. So the instrument that we use, no, that is called out as dip circle. So magnetic needle is there. It's just like a box type structure is there. And you are having a magnetic compass where proper needle is being drawn. Needle is present. And this is held onto the stand like this. This is some sort of, I do not know the details of this. What I know and what is useful for us is that the structure within this, just the needle part, what are all the coverings and all, that is not even useful for us. And I also don't know the structure in very much detail. What is important is that this needle is actually like this. This needle is present. This point, there's a point mark that gives us the direction of the horizontal. Horizontal will depict the magnetic meridian, right? And here the entire degrees are marked like this. Like this. So if this will be 90 degree, if this is 0 degree, this will become 90 degree like this. Now suppose this needle will rotate. This needle has rotated, and let's say this has stopped at a. Suppose this has stopped at this point. This is the needle and this is the pointer, and it has stopped at this point. All right. Now this point is actually giving the direction which has been obtained by the instrument. This occurs in here. I am just telling you the structure within this in elaborated form. Now see this part that has occurred, this much of angle, this gives the dip. This is how a dip circle looks. And what is this indicating? What is this indicating? This arrow, the pointer is indicating direction of Earth's magnetic. This is indicating direction of Earth's magnetic field. This is how a dip circle works. All right, that's all that you have to remember. One more thing that I'll tell you just. See, when a perpendicular is drawn, a vertical plane perpendicular magnetic meridian is taken, then you consider the angle of dip to be 90 degrees. If vertical, let me write it down. For vertical plane, if a vertical plane perpendicular to magnetic meridian is taken, then you take angle of dip as 90 degree in your calculation. All right. The rest of it, there is nothing else that you should remember. Let's see some questions also. First, write it down. All these points, especially this is not there in your CBSE. This is a part of this. From here, quickly write it down. Still not much time is left. Very basic question, let's see. Then next Wednesday, we'll complete with the questions. A very basic question I want to discuss. See, this question says that horizontal component of Earth's magnetic field, no, this is actually √3 times the vertical component. You have to find out the angle of it. So very, very easy question. This is C. BH is equal to √3 times BV. And what is tan theta? Tan theta is BV by BH. So when you put in the value of BH, this becomes BV by √3 BV. This gets cancelled. Tan theta becomes half. So theta is 30 degrees. Very easy just to understand the usage of questions. We have 1 or 2 good questions from this that I want to discuss. In the next class itself, we'll complete this lesson. And if time is left, then we'll start with EMI also. So I just want to discuss lots of questions that are there from this. First, note this down. Okay, on next Wednesday, we'll continue then this. Please just revise this magnetics and come. Earth magnetism we have to complete and then we'll start with EMI itself. All right, thank you so much. Please revise and come.
Thank you, ma'am.